This next section in systems of equations is solving them through what's called the elimination method. What we're going to do is we're going to try and eliminate one of the variables, whether it's x or y, in the problem, and that way it'll help us in finding the point or ordered pair that actually works for the system. Sometimes this is used when it's not as easy to graph it and it's just easier to do this way. So pay close attention to this one. There is some stuff in here that will be a little tricky at the beginning, but once you get the hang of it, it actually works pretty well. So here we go. So what we're going to do is we're going to use addition and subtraction properties of equality. This way we can eliminate one of our variables, and that means just get rid of it. So the way we do that is we always try and get rid of one of them by looking at, in this step one, can you add the two, when you add the two equations together, you notice that this y has the same coefficient, they have opposite signs. So if we have the same number, different signs, it always goes to 0, and that eliminates our y because the 0 would be multiplied by y to get rid of it. So in the bottom equation, what we have is we actually do the combining of these two equations. So we take a positive 5, positive 3, get us an 8. We take our negative 6, positive 6, we end up with 0. That's what we want. And then we reduce the rest of it, and we subtract the 2 out here. This is going to get us 8x equals 16 because we don't really need this 0 in here. So we can just divide by 8 to both sides. And that's where we will use some of the properties of equality here. So we have a one-step equation, and we solve for x in this case because we got rid of y. So what we're going to do is we're going to take that x now, and we're going to put it back in for an x in one of the equations. And you can choose either one, it does not matter. But remember, you are using the x equals 2. So you're going to put the 2 in for where you see the x, and then you're going to solve a two-step equation in order to find what y is. So in this case, we put our 2 in for our x, we multiply, we solve it for the y by moving our 6 over here, gives us a 42 because we'd subtract, and then we divide by 6 here, and that would give us 7. So we have an x of 2, y equals 7, but we want to make sure that we check everything to make sure that it's absolutely true in this. So take a moment, throw them back into both equations, and you work through the steps for each one of the steps in the equation. Just replacing the number, and it's basically an order of operation problem. Where does the left side equal the right side? So the ordered pair 2, 7, if they both work, in regards to does it come out equal, that will tell you that it's true, and that is actually the solution. So on graphing, at 2, 7, this is where your lines would cross. That's what this means. But we're just doing it a little bit differently because you're not always just going to get an equation. You're actually going to get a word problem. So in this word problem, we have 292 tickets for a basketball game. The adult tickets were $3. The student ticket cost $1. They collected 470. What we want to do is we want to write and solve a system to find the number of each type of ticket sold. So we want to know how many adult tickets and how many student tickets were sold, and we can do that through a system of equations. So if we look at this, we're going to let A equal the number of adults tickets, S equal the number of student tickets. So the total number of tickets is A plus S equals 292. So we sold 292 tickets because we have an adult and we have a student ticket. In the other part, we have the 3A plus 1S equals the 470. Well, the adult tickets cost $3, the student ticket cost $1, and it came out to be the value in money of $470. So there's two different equations that you're going to work with. So what we're going to do is we're going to solve by elimination, and we're going to do this one by the difference of this. So when you do it by the difference, you are simply multiplying it through with a negative sign. So that means that you must subtract the two equations. So you have negative 3A minus A equals a negative 470 is what you must subtract. So we're looking at getting rid of the S in this case. So this should actually be an S over here. That was my mistake. So when you do that, this changes the sign to a negative. So these two go and eliminate each other. So now we're left with a negative 2a equals a negative 178. We're going to divide by a negative 2. That gives us a equals 89. So that is the number of adult tickets that we sold for this. So again, that's why it's important for your letters to represent what you're doing in the problem. So when we do this one, now we're going to substitute the a back in, and we're going to find out, and I always take the easiest one, because most of the time, 9 times out of 10, you're going to end up with an equation that's just a letter plus a letter equals a total. So use the smaller one. Obviously, that would help because it's just a one-step equation. So we're going to throw 89 back in for A. We're going to now solve this one-step equation for S. So we would subtract the 89 from the 292, and that would give us S equals 203. So the total part of this is there were 89 tickets sold for adults. There were 203 student tickets sold. So now is the solution reasonable? So throw that back into the other equation that has the dollar amount, where we said that each adult ticket was $3, each student ticket was $1. Take care of the multiplication, add the two, and they will get 470 on both sides of the equal sign. So there is some work to do on this one, so you've got to be careful. The next one we're going to have is where you don't see the obvious. So we've gone through a couple of examples that have been very simple in regards to I can eliminate this variable either by just simply combining them because they have opposite signs, or I distribute a negative through one of the equations. So if you look at the first equation, you notice that these can just eliminate themselves because they're the same number and they're opposite signs. Same with here. We have the same coefficient, different signs, so they would eliminate each other. The problem with this last one is there's none that are the same. So what you have to do is you have to come up with, okay, how can we do this and change the equation to make it equal to one of the variables in there with the coefficients. And that's the tough part. That's the part that you want to take your time on. So when we solve by elimination of the two equations that don't really matter or don't have a common one in, we have to ask a question. And that's down here. Is one a coefficient factor of the other coefficient for the same variable? So can 2 go into 10? And if you can find that, that's what you want to take care of. So we're going to go with, to do this, we're going to prepare for the elimination of x by multiplying it by 5. So we're going to distribute the 5 into the parentheses. That's going to give us 10x plus 25y equals a negative 110. So we've multiplied the 5 through. What we're going to do with the bottom one is we're going to take care of and eliminate that one. We're going to subtract it. So remember, when you subtract it, you have to take that negative into each of the terms. So that changes all of your signs to a negative. So if you go up to the top with me, it says be careful when you subtract, all the signs in the equation that is being subtracted change. So we really have negative 10x, negative 3y, and a negative 22. So we eliminate the x. We come up with a 22y due to the fact that we're subtracting these numbers and we're subtracting these numbers. But because they're the same signs, we actually add them. So here is what, when we solve for y, divide by 22 to both sides, we end up with a negative 6. So that's one of the solutions. Now we're going to take the y equals negative 6 and we're going to plug it back into the easier of the two equations. So when we do that, we're going to take our negative 6, excuse me, and we're going to plug it back in for y. So we have 2x plus 5y, but now we have a 6 in there. So we multiply these two, gives us a negative 30. We're going to solve the two-step equation by moving the 30 over. We're going to divide by 2 at the end, and that's going to give us 4. So the solution in this one is 4 and a negative 6. So again, you'd want to check when you get done with that. So again, you want to look at what the equation is can I eliminate one of the variables right off the bat? So in this case, I could eliminate the 5s. I really can't eliminate something right off the bat, but I do ask the question, can 10 go into 40? And the answer would be yes, so I would multiply this one simply by a 4, because this is already opposite signs. If here I could do the x, I could take away and get rid of the y. The y might be easier because all I'd have to do is multiply it by 3. In this case, the 2 might be easier. In your case, if you think about it, you'd all have to do is multiply by a negative and distribute a negative through it. So there's different ways of where you're looking at and trying to get rid of what you're trying to do with the equation. So if we eliminate a variable, you need to multiply the equation by a non-zero number, meaning multiply by a factor. Okay, so multiplying each equation by the value, so you're using the distributive property. When you add or subtract it, you eliminate that variable. So in these two equations, you cannot use graphing or substitution. However, if we multiply the first equation by 3 and the second equation by 2, we can get rid of the y. So when we do that, we're finding basically what is the least common multiple or the common denominator for this equation in the sense of what's the easier. Now we could have done it with the 4 and the 7 because that would have been 28. We would have multiplied the top one by 7, the bottom one by 4. And remember, you're multiplying it by every term in the equation. So when we do this, we're going to multiply the top fraction by, or equation by 3, the bottom equation by 2. So in the middle step here, we're distributing the 3 into everything, and that's what gives us the 12x plus 6y equals 42. In the bottom one, we're distributing the 2, and we're going in and taking this and going with 14, a 6, and a 16. We do not have to worry about negative or positives because we can combine those and that automatically gets rid of it. So we have a 26x equals 26, which just gives us x equals 1. Then we're going to take the 1 and we're going to stick it back in for x. And we're simply just going to solve this part and do a two-step equation. So move the 2 over, or excuse me, the 4 over, gets rid of it, gives us 2y equals 10. Divide by 2, and that gives us 5. So the solution comes out to be 1, 5. So there are some steps in here, but again, if you keep everything straight, everything should work pretty well in what you're doing. So we're using the distributive property, we're using elimination, we're using combining of signs. So we're bringing back a lot of stuff that we've already done. We're just putting it into a different form. So when you're solving these, you have to kind of plan a strategy. You have to know what you're going to do before you actually start doing it, and will it work? So the question is, can I eliminate a variable by adding or subtracting the given equation? So if I can do that, then yes, go ahead and do it. But if I can't, then I have to multiply it by either a least common multiple or I have to multiply it by a negative. And that way I can reduce it and get rid of that one variable. And that's all we want to do is get rid of the 1. So if I can do that, then do it. Now, if I have to multiply both equations by different numbers, then I have to do that. So there's ways around it as you look through these. Do I take it just by a negative? Do I just take one equation and work with it? Or do I have to work with both of them? And that's the part where you have to really start looking at the problems in what you're doing. So be careful with those as you go. So as you're looking through this, the best time to solve and best time to use the method is, and one of the methods that I have up here is what's called substitution. You'll do that more in Algebra 1. We will do the graphing and we will do the elimination part. So you can look through these, see what you have to do, choose the best one that you want to take care of, and that's what you want to use and go with. But be very careful in how you set up your problem. Be very neat, be orderly down the page, and that way you can see everything that's working for you. With that, ask your questions, work hard, and show your work.